So when we're completing this one, we want to do the long division for it. So you just have x minus 1 divided by, and you want to have here x 4 plus 0x cubed plus 0x squared minus 1. And you have to remember to put those zeros in because they are placeholders still. You can't just write it out without them. So you want to make your leading coefficient the same as this leading coefficient, so let's just multiply by x cubed. So we have x4 minus x cubed, and when we subtract them, we get here just x cubed plus 0x squared. Well, when we want those leading coefficients to be the same, we add the x squared plus x cubed minus x squared. We minus them from each other again, you get x squared minus 1. Oh, never mind, I forgot the x term. Plus 0x minus 1. So that comes down plus 0x. So we have x here, x squared minus x. Subtract those, you get x minus 1. All right, x cubed. Oh, that's where my mistake is. I was going to say, this looks a little bit wrong. Okay, I forgot the x term. Plus x minus 1. So we brought that down. You had plus x here, which made it minus x here. When you subtract those, you get 2x minus 1. And to get this, we do times 2. So you get 2x minus 2. When we subtract those, you get 1 remainder. So really, this is x4 plus x minus 1 is equal to x minus 1 times x cubed plus x squared plus x plus 2 plus 1. When you're going to factor this, remember we're going to use our factor theorem. So we're going to try, we really just have plus or minus 1 to try. So f at plus 1 is 4 times 1 cubed plus 4 times 1 squared minus 1 minus 1, which is 4 plus 4 minus 1, which is going to be equal to 6. So that doesn't work. When we have negative 1 here, you have 4 times negative 1 cubed plus 4 times negative 1 squared minus 1 minus 1. So this becomes negative 4 plus 4 plus 1 minus 1, which gets us our 0. So that's one of our answers. And then we can use, like I've said before, you can use synthetic division where you have 4, 4, negative 1, negative 1. That becomes 4. Negative 1 becomes 0. You have 0 here, you have negative 1. And then we have positive 1, which becomes 0. So then you have 4x squared minus 1 and x plus 1. And when you do difference of squares here, you have 2x minus 1, 2x plus 1. When you're describing your x-intercepts for this one, it's nice and easy because it's already factored for you. Our x-intercepts are negative 3, positive 4, positive 3. My y-intercept, plug in f at 0, and you get negative, and this is 3 times negative 4 times negative 3 squared, which is going to be equal to negative 3 times negative 4 times 9, which is going to be negative 108. And when you describe your end behavior, so the x-intercepts, you want to, because this is degree 4, and its leading is negative, you want to you know that as x approaches positive infinity and as x approaches negative infinity, they're both going to approach negative infinity, because it's going to look something. At -3, it's going to go through. At +3, it's going to bump. And at 4, it's going to go down again like this. On the last one here, just want to factor it first. So you basically take out an x first, then you have x cubed minus 7x minus 6. And after this point, you're going to have to use the factor theorem or remainder theorem to figure out one of the answers that works for this. You could try -1 or +1. If we try +1 here, and we just check this one, it'd be 1 cubed minus 7 times 1 minus 6. Well, that's 1 minus 7 minus 6. Well, that's not going to work out nicely. It's not going to be 0. F at -1. -1 cubed minus 7 times -1 minus 6. Well, this becomes -1 plus 7 minus 6, which is exactly 0. So that's one of our nice pieces here. 1, 0, -7, -6. That's 1. That's -1. That's -1. That's 1. That's -6. That's 6, and that's 0. So what we're left with right now, we have x plus 1, because it's always the opposite of the factor that works for it. And then we have x squared minus x minus 6. And thinking about this from before, you have x plus 1, and this is x minus 3, x plus 2. Because you're looking for two numbers that add to make -1 and multiply to make -6. Now that you have your x-intercepts, you have 0, -1, +3, and -2. You know it's degree 4, and it's positive, so the end behaviors are just going to be as x approaches infinity and as x approaches negative infinity. They're both opening up, so y is going to approach positive infinities for both of those. And the nice thing is, if you have an x-intercept of 0, you know that your y-intercept is also going to have to be 0 as well.